Okay, Nathan says action. So good morning, boys and girls. Today in 8th grade math, we are working on analyzing data. You're going to learn some important vocabulary words. Today, to do this, we're going to look at simple bar graphs and how the data works. The same principles apply to other graphs. We're going to stick to one variable. On today's assignment, you're going to be trying to identify certain parts of the data. So if you have a bar graph that looks something like this. Okay, so in this case, the biggest part of the graph, where there's the most data, is called the peak. So if this was like 1, 2, 3, 4,
that guy looks like
5,
a staircase.
6,
Right
7,
there.
8, 9. The peak would be between 4 and 5. Yes.
It
I
kind of
understood.
looks like a staircase.
Okay, so Nathan says it looks like a staircase. Also, another term you could use for this is this data looks fairly symmetric. Nathan is very active right now. Symmetric data look fairly similar on the left side and the right side. Now, students say, Mr. Davis, it looks slightly different. As long as it's roughly the same, it's considered symmetric. It's not perfectly symmetric, and if your data is perfectly symmetric, someone's probably lying to you. Actual data is a little bit more iffy more often. So you have to be able to identify the peak. The peak is between 4 and 5 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the data looks roughly symmetric. Okay, we're going to also talk about two other vocabulary terms that help us in analyzing data. Also, a fancy math term you'll learn later on when you're in high school. This data looks fairly normal, where there is this roughly symmetric peak in the middle, no other issues. A lot of data in the world shows up with looking like this. For instance, height is fairly normal, as many other things. If you ever heard someone say little Bobby's in the 80th percentile, that's they get from these kind of curves. If you do more statistics, you will do a lot with normal data. My wife, who's in a stats class right now, is nodding her head because she has to do a lot with normalized data. Very important. But not all data is normal, so let's talk about things that happen that make it not normal.
Let's make one is not actually normal.
Okay. Nathan says it, let's make it happen.
I'm making a staircase again.
These are called histograms, not staircases.
Oh, they're histograms.
Yeah. Okay, so this data could represent income, for instance. Lower ranges have most of the income, then it tapers off, and then there's some very wealthy people up here. So, in this case, this range down here is called the gap. So, in the assignment, they'll be asking you where there's a gap in the data. The gap just, thank you, Nathan. The gap just means where the data has missing amounts. So for instance, in my previous school I taught at, the vast majority of teachers were normal size height, and we had a 6'11" teacher. There was a large gap in the height between us and the former basketball player, who actually did play basketball. Okay, and then very often if you have a gap, frequently you have what's called an outlier. The teacher I was just talking about is an example of what's called an outlier. An outlier is a number that sticks out far from the rest of the data. And once again, if you extend your further math career into college, they'll actually be able to have strict definitions of what makes something an outlier. For our purposes, just visually look and see, does it really stick out? Yes or no? Let's find out. This could be an outlier, it could not be, depending on what happens. For our purposes, visual inspection is good enough. If you actually really care, it's 2.5 times interquartile range plus Q3 or minus Q1 as Nathan moves my weight. Okay, so 4 terms you have to know for today's assignment. Symmetric, if it looks the same left and right, roughly. The peak, where the top part of the graph is, in this case, this is the peak. And if you're using one variable data, the peak you're going to define as these numbers down here, whatever they are. Gap, where is there data missing, and you can have more than one gap. An outlier, where the number is really sticking out. You don't always have to have an outlier, you do have to have a peak. You can have more than one outlier, but most of the time that's unlikely. However, there are a few if this actually was an income graph, vast majority of people make between $10,000 to $150,000 or so, roughly. And there are a few people who make millions, if not hundreds of million dollars. Warren Buffett, Bill Gates, etc. There's more than one outlier in that regard, but they make far more than the rest of the world does, on average. Okay, so that is analyzing data. Once again, if you have questions, feel free to ask me. Richard.davis@slcskills.org. I do respond to emails. And of course, good luck.
And of course, good luck.
And
Yes.
bye.